So hello and welcome everyone. I am Jay Dalsaniya and in this video we are going to solve the question sum of dependencies in a graph. The question is labeled as easy. It does not require very much complex algorithm or intuition is not required. So this question is going to be very easy. So let's try to understand what to do in this question. So let's start. So in this question, you will be given a directed graph with V nodes and E edges. If there is an edge from U to V, then we'll say that U depends upon V. So number of dependencies, that is NOD, for a node X is the total count of nodes that X depends upon. Find out the sum of number of dependencies of every node. So basically in this question, we have to find out for the given directed graph, we have to find out the total count of dependencies of every node. And whatever is the sum of dependencies, we have to print it in the output. So that is the question. The question is pretty simple. So now let's try to understand with the help of a test case so that we can have a clear understanding what does it mean by dependencies. So over here I have taken the same example which is given to us in the question, and over here in this example V and E denotes the number of nodes and number of edges respectively. So V is for the total number of nodes and E is for the total number of edges, and the edges array is given over here. So let's try to draw a directed graph out of this given edges array. So it says 0 to 2, so there will be an edge from 0 to 2. So 0 to 3, right? So this will be the edge, and 1 to 3, so there will be edge from 1 to 3, and 2 to 3. So this is how the graph will look like. So now it has been mentioned what is the definition of the dependency. Let's say there is an edge from U to V, then it has been said that U is dependent upon the node V. So the dependency of the node U in this scenario comes out to be 1 because there is an outgoing edge from U to V. So basically according to this question, the dependency is the total number of outgoing edges from a node. So let's try to mark down what is the dependency of every node over here. So let's start with the node number 0. So over here you can observe how many outgoing edges are there. I can see 2, so the dependency will be 2. For this node 2, how many outgoing edges? Only 1. For this 1, how many outgoing edges? 1. And for this 3, how many outgoing edges? 0. So what is the count? That is 2 plus 1 plus 1 plus 0, that comes out to be 4. And hence the output for this test case comes out to be 4. Right? I hope you understood what is the meaning of dependencies according to this question. Okay, so that is the question, and we have to just print the sum of the dependencies. So now let's try to understand what can be done in this scenario, how to find the total number of dependencies. So according to the definition, I can just convert the given definition of this question into a single statement, that is you have to count the number of outgoing edges. Count the number of outgoing edges. Outgoing edges of every node. So in a directed graph, when can you think, like what is the scenario that will say that this node has an outgoing edge? Whenever any node will have some adjacent node, at that time only that particular node will have an outgoing edges, right? So what you can do in this graph, for each and every node you can simply count the total number of adjacent vertices. Okay, so in this question you will be given an adjacency list. And how does an adjacency list look like for this test case? Let's have a look. So if this is the test case, then your adjacency list will look something like this. So let me just copy this entire test case over here, and let's analyze it. So in this question, the edges array has been displayed, right? But over here, according to the problem statement, according to the pseudocode which is already given, you will be passed an adjacency list. So adjacency list of this graph will look something like this. So we know that for 0, how many adjacent nodes are there? I can see 2 and 3 are the adjacent nodes. For 1, how many adjacent nodes are there? I can see only 3. So for 2, how many adjacent nodes are there? 3. And for 3, how many adjacent nodes are there? So the adjacency list contains 0, right? So on this adjacency list, what you can do, you can just iterate over this entire adjacency list, and one by one for each and every particular node count the size of the list. What is the size of this adjacency list? 2. What is the size of this adjacency list? 1. What is the size of the adjacency list? 1. And over here 0. Just keep the sum of this total number and you will be getting the total count of dependencies for the given directed graph. That is how we can solve this question. Okay, I hope you understood how to solve this question. So now let's get back to the coding implementation for the same, and let's try to write down some code. So over here I've written down the code in Java, but the same can be implemented in other languages, right? So you can take the help of this code. So this is the sum of dependencies method, and in this method you have to write down the entire logic. See, as an argument, as I mentioned, you will be passed an adjacency list, right? So over here an array list of array list that represents an adjacency list in a graph has been passed. Okay, and V denotes the total number of vertices. So now what I have done, I have taken a local variable, that is sum variable, initialized to 0. Now I am iterating over each and every adjacency list. Okay, so I'm just fetching the adjacent nodes, that is the list of adjacent nodes, and I'm just calculating what is the size of each and every adjacent node, right? Basically, what is the size of each and every adjacency list, and I'm just keeping the size added to the sum variable, and at the end just return this value of the sum variable, and that's it. Okay, no complex. So it is not very much complex to understand, and let's try to compile and run, and let's see what is the compilation. So the compilation has been completed, and let's try to submit this as well. And we can see that the problem has been successfully submitted, right? So let's try to analyze the time and space complexity. So what do you think, what will be the time and space complexity? So over here, if we analyze the time complexity, there is a for loop inside this logic, right? And this for loop will be iterating over the entire adjacency list. So how many lists will be present inside an adjacency list? The total count of the list will be equivalent to the total number of nodes present inside the graph, right? For each and every node, you will be having an adjacency list, right, inside the adjacency list. So the overall time complexity of this approach comes out to be order of V, that is total number of vertices, and the space complexity in this scenario is constant. I am not using anything extra that depends upon the size of the input test case, right? So that is the time and space complexity for this question. So that was the entire implementation and coding part for the question sum of dependencies in a graph. I hope you really enjoyed this solution, and if you really enjoyed this solution, do hit the like button and share it with your friends. So that was it for in this video, and I'll see you in the next video.